So now we're going to get into a more formal look at hypothesis testing. There's going to be some vocabulary in here that as we use it, it'll become more and more familiar to you. But hopefully you've seen hypothesis testing before. It might be a review, but it is kind of technical, the language, but we will be reviewing it. And actually, the nice thing about the course is that for the rest of the course, most of our topics are hypothesis testing, so you'll see this vocabulary used over and over again through the course of the semester, and as we do that, it will become more and more familiar. So in general, there's 4 steps to hypothesis testing. The first step is to hypothesize. We state some kind of claim that we're interested in investigating. We prepare, meaning that we're going to make sure that we have all of our assumptions for whatever test we decide we're going to use satisfied. We compute some kind of test statistic and a p-value that goes along with it, and we'll talk about what these are in a moment. And then we interpret what we just did. So this step here is always done using technology. All right. Let's take a look at those 4 steps again in more detail. So the first step was hypothesize. So there's always a pair of hypotheses. The first hypothesis is called the null hypothesis, and it's abbreviated with the capital H and a subscript of 0. So the null hypothesis is the neutral or status quo hypothesis about a population parameter. And what's important is that it always contains an equal sign or equality. The second hypothesis is called the alternative hypothesis, and it's abbreviated with a capital H and a subscript of a lowercase a. Some people abbreviate it with a subscript of a 1 also. Those are just 2 different styles you might see. And that's called the alternative hypothesis or the research hypothesis. And it's a statement about the population parameter that we'd like to demonstrate is true. And it always contains one of these symbols, a less than sign, a greater than sign, or a not equal sign. And these hypotheses are always about populations. So in other words, they're always about parameters. They're never about sample statistics, because sample statistics are things we can measure. Okay. So there's something called one-sided and two-sided hypothesis testing. So if your alternative hypothesis has a not equal sign in it, then it's what's called a two-sided test. And if your alternative hypothesis either has a less than sign or a greater than sign, then it's called a one-sided test. And as we do examples of this, you'll see why these words are used. In every hypothesis test, there's something called a significance level. So the significance level is the probability of making the mistake of rejecting the null hypothesis when in fact the null hypothesis is true. So the symbol for the significance level is this symbol right here, and it's called an alpha. In the Greek alphabet, it's a lowercase a. So traditionally in research, the significance level of 0.05 is used. So that's usually the alpha that you'll see in most research studies. The smaller the p-value, the stronger the evidence against the null hypothesis. So let's kind of try to tie back some of this vocabulary to that example that I had done earlier about the case of discrimination. So while that isn't a numerical case about means, which is what we're going to be doing in this lecture, it kind of gives you a framework for hypothesis testing. So if we think about that hypothesis test, all right, our null hypothesis would be that there's no discrimination going on. That's like the equality sign. Everything's good, there's no discrimination going on. And our alternative is that there is discrimination going on. So what we decided to do is we decided to take a look at this with a simulation, all right? And so we collected data. And so down here, we talked about something called a p-value, all right? So, or a significance level. So the question was, when we did our simulation, we found out the probability of only getting 14 women promoted in a set of 35, if there's no discrimination going on, was 0.02. So if we use the significance level of 0.05, what we said is, wow, this is very unlikely. And what do we mean by very unlikely? It's less than a standard significance cutoff of 0.05. In other words, it's very surprising. So what did it cause us to think? It caused us to think that our null hypothesis could not have been true. And so we believe that the alternative is true, that there was discrimination going on in that case. So I just wanted to kind of tie back some of these words that we're using to that initial problem or case that we looked at. And again, this will be much more clear as we get to an example. And an example is coming. Just hang in there for a little bit. Okay. In every problem, there's something called a test statistic, which I said we were going to compute with technology. So the test statistic compares our observed outcome, what we found in our study, with the outcome we would get if the null hypothesis was true. So if the null hypothesis is true, our test statistic should be close to 0. And when the test statistic is far away from the value we would expect if the null hypothesis is true, then we would reject the null hypothesis, and we would believe that the alternative is supported. So in cases where the test is based on the central limit theorem, like the cases that we're going to talk about today, the test statistic you can think of is in the form of a z-score. Just a few more words, I promise, and then we're getting to an example. So a p-value. The p-value is the probability that if the null hypothesis is true, we would see a test statistic as extreme or more extreme than the one we've got in our sample. So that's why I said back here, if we think about our case of discrimination, our p-value was 0.02. The probability of seeing only 14 women promoted was 2%. We saw that in our simulation. In other words, that was highly unlikely. So we didn't believe our null hypothesis was true. So when our p-value is small, like in our case of discrimination, we would be very surprised if the null hypothesis are true, so that discredits the null hypothesis. In other words, that's why we figured there had to have been, or was likely that gender discrimination was going on in that case. So if our p-value is less than our significance level, our p-value is considered small and you reject the null hypothesis. If your p-value is greater or equal to your significance level, then you're not surprised and your p-value is not considered small and we don't reject the null hypothesis. So sometimes I think about it kind of like as a number line. So p-value is a probability, so it's going to be between 0 and 1. So you have this cutoff here, which is your alpha, and again, that's usually 0.05. And in this region, you're going to reject the null hypothesis. You don't believe it's true because your p-value is so small. If the null hypothesis is true, that would be just unusual, highly unusual to get the sample that you have. And out here, we do not reject the null hypothesis. So any p-value that's greater than your significance level, usually 0.05, you don't reject the null hypothesis. Now, I know there were so many words there, and you maybe remember some of them. Maybe some of them are new. Maybe you never really understood them the first time you took statistics. All right, we're going to do a couple of examples and hopefully put all of these pieces together.